In section 4.4, we use prime factorization to find the GCF and the LCM. Okay. So when we originally set up this curriculum, we used Venn diagrams, and the students found it very confusing. So here, we developed another method. Okay. So first, we talk about greatest common factor. We look at two examples, have them list all the factors. So this is the first method. List a bunch of multiples till you find the common multiple. Okay, and we find the GCF and the LCM. Okay, so again, this can be tedious if the numbers are really large. So we want to have another method of more directly finding the GCF and the LCM if needed. So let's look at this example with 8 and 12. So this is probably not a way that you've taught GCF and LCM before. If we have 8, its prime factorization is 3 factors of 2. If we have 12, it's 2 factors of 2 and a factor of 3. Okay, and then we have them find the list of common prime factors, including repeated factors. So the GCF is 2 times 2. Okay, and then the LCM. Okay, this we're going to look at another way in just a second, but the way you may have taught the LCM before is that here's their GCF. Okay, the LCM is the union of these two sets, where we think of these factors of 2 as distinguishable, and that's why it gets pretty tricky for students. Okay, because they seem to confuse. They think of all the 2's as the same, and they think of them as one big set of 2's. Okay, so notice here we say the LCM of 8 and 12 is their product divided by their GCF. So notice if we take the union of these, thinking of these as all different, it just removes 2 of the factors of 2, which is the GCF. So the LCM is the product of these numbers. Okay, so just think of these as the original numbers instead of their prime factored form, and divide by the GCF, which would give us 24. Okay, so of course this isn't a formal proof, okay, that this will always work, but this really helps them because they typically confuse the greatest common factor and the least common multiple. We use the word greatest and it's the smaller of the numbers. We use the word least and it's bigger or equal, at least as big as these two numbers. Okay, so the terminology can be confusing. So this method allows them to always find the greatest common factor first, even if they're going to find the least common multiple, and then connect the least common multiple to that greatest common factor. So they won't just stop at the greatest common factor. Okay. A nice way to justify this to them better or help them use patterns to see these connections is take a couple of examples. So maybe you can do 8 and 6 with small numbers, have them find the GCF using the other method like we did on the previous page. The least common multiple is 24. Okay, and then ask them to find the product. So the GCF times the LCM is 2 times 24. And the product of the two numbers is 8 times 6. So if they do a few of these and see that the product of the two numbers equals the product of the GCF and the LCM, they'll see that connection more clearly. And then you could ask them to find some least common multiples by only finding the GCF and then dividing like we did here.